Welcome. We'll slowly get started. My name is Kai Kalech. I run Environmental Instruments Canada, and we make the Radon Sniffer. In this learning lab, we will talk about how one would use the sniffer to inform mitigation methods. Just a little bit of background on our company. EIC was formed in 1998, and so a little bit over 20 years ago. And we started off as servicing uranium mining companies with their radiation safety needs. Since then, we've kind of diversified. We make handheld radiation detectors for hobbyists and also for homeland security applications. And of course, we also make the Radon Sniffer. My personal background is I went to school for physics, and my professional background is fixing radon problems in uranium mines. So I do know a little bit about radon, but I am not a building scientist and I'm not a mitigator. So I don't pretend to talk about this with a whole lot of authority. So if I'm making some mistakes about what we're talking on the subject that we're talking about today, please let me know. If you can stay muted until we'll watch a couple of videos about this, and then we'll throw it open for discussion. And yeah, if you just want to then unmute yourselves and ask the questions rather than typing them in the chat window, which I probably won't find. So let's jump right into this. The theory about looking for sources
Let's
for
look at how
mitigation.
radon enters a house. In this example, we have a fissure in the ground where radon comes up, a gravel layer underneath the house, and footings. The middle footing is a strip footing. The footing on the right has some penetrations and therefore is not airtight. Radon enters the house through openings, such as a crack in the basement slab. So, how does this get mitigated? The usual mitigation process would begin with a communication test, where holes are drilled through the slab. The mitigator would make a larger hole and apply a shop vac to see if there is a connection to the other holes. Normally that test would be made wherever the most convenient place for a mitigation system would be. In this case, that might be the hole on the far left. In this example, the communication test would reveal that there is communication to the middle hole, but not the far right hole, due to a type of blockage. In this example, it's strip footing, but a blockage could be caused by many things. So, the mitigator would then put the shop vac on the middle hole and hope that it would communicate with the other holes, but in this case, we're still not communicating with the hole on the right. To resolve this, the mitigator would run a jumper to a part of the slab where there was no communication. The theory is that radon is diverted from the crack and is exhausted. The flow through the crack is reversed and the basement air is drawn below the slab and exhausted with the radon fan. The problem with this method is that a lot of energy is wasted sucking in clean air from the outside, and in the winter this leads to cold walls and floors. It also lowers the suction on the other side by pulling in outdoor air. Plus now you have a large unsightly jumper. Even worse, the problem might not have even gotten solved. In theory, the mitigator depressurized the entire slab and reversed the airflow through the cracks, but this isn't necessarily the case. The actual pressure at the crack was never measured. There might not even be access to the crack if it is at the expansion joint under a finished wall. Another consideration is that the mitigator may have depressurized the whole slab now, but what about 6 months from now when the water table is different? What about when the house's HRV intake is plugged, depressurizing the house? Maybe then the entire slab will no longer be depressurized with respect to the house. By sucking on the subslab, the mitigator could be bringing in more radon from below. So yes, the airflow through the crack is decreased, but there may have been an increased concentration of radon in that air. Instead of starting with a communication test, some of our customers start by using the radon sniffer to check for radon sources. Where a source is found is where the test hole would be placed. Then the mitigator would check for communication to that hole. If there is no communication to a hole that doesn't make up any radon, then there isn't a need to worry about it, and the mitigator would just seal it up. Then the mitigation system would be put where most of the source is, or at least where there is good communication with the source. Therefore, the radon will be moved directly, without first being dragged all over the underside of the slab. Because a test point is close to the radon source crack, the likeliness of not having enough suction to maintain the airflow in the right direction is much less. There also isn't a waste of suction bringing in clean air from the outside.
And we'll just show a video about how this would be used in a block wall, not through the slab itself.
We're heading to the job site this morning. We're going to get the sniffer going, clear out any residual from the past job. The house we're going to be doing this morning is going to probably be a block wall depressurization. It's going to present a little bit of a challenge, I think, but we're going to hopefully rely on the sniffer to help us sniff out the radon at this house. We're down in the basement and we have our sniffer going in this block wall, and it's been anywhere between 1,000 and 14 picocuries. We have our suction hole, and the pipe leads to the outside fan. This is taking care of this entire wall that we were having high levels between 1,000 and 1,400 picocuries. Again, we were able to communicate through the other side wall. And again, this is where our pilot hole was, and we were able to communicate. Finish up with the fan and set a test and see what the new levels are. Here we have the completed install fan, drawing the gases from that block wall that showed elevated radon.
Let's discuss what we just saw. The mitigator began by running the sniffer in clean air at the start of the day. He then took measurements at the 4 walls shown in the visual. The video shows the mitigator measuring hole 1 and getting high levels of radon. He also got readings of radon on hole 2, but not at the other holes. So, he only had to focus his attention on hole 1 and 2. He put the shot back where we see the larger hole in between hole 1 and 2, and was able to get a connection to both holes, meaning he didn't need to make any other further installations.
Sometimes you don't necessarily want to drill holes all over the place if the place is already finished, so you don't want to necessarily do all your diagnostics like that. So some people are using the sniffer without actually drilling holes through a slab. In this case here, that is a commercial job at a university. This is in Canada, so the units that are shown here, the 3700, that's in becquerel per cubic meter. So that's 100 picocuries per liter. So he's sniffing below a bathtub in I think that's in a university dormitory. And he's finding 100 picocuries per liter. After that, he is putting a borescope down, and he found that there is a gap between the concrete slab and the drain. So after that, he sealed that gap, and that helped the radon levels. As well, this is in Europe, and so here he's seeing 38,000 becquerels per cubic meter coming out of the baseboard there. There's No holes drilled into the floor, just a straight sniff on the basement, on the baseboard. 38,000 becquerel per cubic meter is 1,000 picocuries per liter. So that is a healthy source. And the way he's getting that is he put a blower door on the house and depressurized the house to minus 30 pascals. So that helps, that increases the radon sources, and he can go around with the sniffer and just sniff directly to find sources, and he doesn't have to drill holes just randomly. So now he's found the source, and now he can plan his mitigation. So we have another video of how the sniffer works in the theory, but maybe I would like to open the discussion up here about how we're mitigating stuff, and then if we still have time at the end, we'll go and watch the last video. So if you want to just unmute yourself and ask questions, go ahead.
This is Nate Burton.
Hi.
Hi. On the Radon Sniffer, does it try to account or estimate the cyclical equilibrium ramp up at all to try to minimize, quick, to account for that ramp up at all?
So the way it works is you have a filter in front, and that takes out the radon progeny. And so what the sniffer sees is the radon gas, and then there will be radon progeny built into building up as the radon decays in the cell, and we have an algorithm that tries to compensate for that. So that's why we're getting the really fast response. People, mitigators will have a bunch of holes drilled in the floor, and they will measure one hole for 90 seconds. That allows the sniffer to stabilize, and then go straight to the other hole without any recovery time.
Mm-hmm. Would the filter also minimize or eliminate the thoron if it's there as a confounding agent?
You still will have the thoron. You won't get the thoron progeny. It is a confounding agent. We are working on a little module for that that'll actually try and quantify how much thoron you'll have. But really, the idea with the thoron is if you're working fast, if you're just going 90 seconds one hole, 90 seconds to the next hole, there isn't really the algorithm doesn't have to work so hard. So all of the buildup and stuff like that isn't that important anymore.
Mm-hmm. Okay. I guess my last question would be, obviously with a lot of high radon, do you have any kind of background buildup inside the unit, or do you have to flush it, say, if you were going to another area?
So yeah, the in real time, the algorithm will try and subtract the background. So that's from between one and one reading and the next. I'm going to get out of this window here. It's going to bother me. Yeah, it's going to be the algorithm was going to handle the background from between one reading and the next. At the end of each day, you do want to flush for at least 10 minutes or so to get all the radon out of there, and then the radon progeny will decay in 3 hours or so. So the next day, then you're starting with a fresh cell. You can over time really contaminate the thing. Like when I was working in uranium mines, I was testing the actual leach cells of the uranium mill, and it didn't take a whole lot. It didn't take very long to build up a background there. But for mitigators in those kind of situations, we really haven't found a significant buildup of long-term progeny.
So you have you have relatively a short recovery time for the unit to go to the next sniffing location.
Sorry, can you repeat that?
You have a recovery time between each radon sniffing location.
Yeah. So what mitigators will do, they will have a bunch of holes drilled, sniff one for 90 seconds, and then go straight to the other one and sniff it for 90 seconds. The recovery or stabilization for these short-term sniffs is that 90 seconds. So each one of them is essentially an independent measurement.
All right, thank you very much.
Welcome. Yeah, there's if you go to our booth, there's some videos that show that. We'll also have a live demonstration tomorrow at 12:30, and yeah, if you want to hop on then, we can show the recovery and all this kind of stuff, and you can ask more questions. So yeah, let's have more questions. I think we still have like 15 minutes to go. So any more questions? Okay, maybe I'll play the theory video then, and we can have some more questions toward the end.
How does the Radon Sniffer work, and some tips on how to use it? The information in this video isn't needed to be able to use the instrument, but it helps some people if they understand the theory of how it works. All you need to know to use the instrument is to start by turning the sniffer on in clean air. Begin to do measurements in areas you expect to be low radon, and try to work your way from low to high, making sure not to turn off the sniffer in between measurements. Don't expose the sniffer to high levels for unnecessarily long, and let the sniffer run in clean air at the end of the day. That's the practical takeaway. Now, we'll get into why. The CT007R uses an internal pump to draw air through a scintillation cell. Before air is drawn into the scintillation cell, any radon progeny in the air is removed by a filter. As radon decays inside the cell, the alpha particle emitted hits the wall of the cell, which is coated with scintillation powder, and emits a flash of light. The photomultiplier converts the light into an electronic pulse, which is then counted. The difficulty with using this principle for measuring radon is that the product of radon decay is also radioactive. The radon progeny tends to play out or stick to the side of the scintillation cell. The higher the radon concentration and the longer the exposure time, the more decay product gets stuck to the wall. The radon progeny continues to emit alpha particles, even after there is no longer radon in the cell. It takes about 3 hours for radon progeny to decay. In other words, unless one can determine the fractions of the pulses that are due to radon progeny, the time resolution will be quite poor, about 3 hours. The radon sniffer calculates how much radon progeny is stuck in the cell at any time, and can subtract that from the total number of counts. You then get a real-time measurement of the radon concentration in the air being sampled. However, there are some caveats to the previous statement. The calculation only works as long as the sniffer is on. So, turn it on in the morning in clean air and leave it on until you're done all your measurements for the day. Then, let it run in clean air for about 10 minutes or so before you shut it off. The radon progeny will decay overnight, and you can start again in the morning. This background process is not perfect. If you expose the sniffer to hundreds of picocuries per liter, you will not be able to measure air with 10 picocuries per liter accurately. So, always do your ambient air measurements before you do your sub-slab measurements. The calculation that the sniffer uses assumes all radon is radon 222. In fact, if you sample subslab air, you'll likely also get some radon 220, also known as thoron, which our calculation doesn't handle well. But if you work fast and don't expose the sniffer to a lot of radon for a long time, the radon decay products don't have time to accumulate and there isn't much correction required. Some mitigators have found success while sampling each hole for 90 seconds and then going on to the next one. The 90-second is a good number. It is enough time to get a few air changes in the cell and for the readings to stabilize without bringing up a lot of radon decay products. The half-life of radon decay products is short enough so that they decay away overnight. But if you leave radon gas in the cell by not properly flushing with clean air before shutting off the sniffer, that has a 4-day half-life. That doesn't disappear overnight. Plus, it will have created radon progeny all night long. The next morning you will see lots of counts and the sniffer won't be able to do its background subtraction properly because it assumes all counts at the beginning of the day are from the radon, not the radon decay products. So, let the sniffer run in clean air before shutting it off to flush out any radon and turn it on in clean air the next time you use it to make sure the counts are still low.
Okay, so I saw about half the participants came in a little bit late, so we'll have a little bit of discussion now, and then if there's a little bit more time at the end, we will just replay that first video about how radon enters a house and how you use a sniffer to help you mitigate it. But yeah, go ahead and unmute yourselves and ask questions.
This is Nate Burton. I have another question.
Sure.
Okay, for the process, you have a calibration process for the unit just to establish some sort of level of traceable accuracy?
So when it goes out of our shop, we cross-reference it in-house, and we say it's good to plus or minus 20% of our reference.
Okay.
It's not intended for legal measurements like real estate transactions and
Right.
stuff like that. It's just to help you do the mitigation. So we don't really worry about too much about absolute accuracy, but and traceability. Where I mean, it's going to be accurate to within plus or minus 10-20%, but we're not too worried about traceability.
Do you require periodic, some sort of periodic factory checks, maybe every year or every 2 years?
We do not. I mean, you're definitely welcome to send it in, but usually people can tell if it's working or not. You know, they will know if I sample here, I should see a lot of radon. If they're not seeing radon, then they give us a call. We get more calls about high background, and that usually ends up being they didn't flush it well the night before, and then they turn it on, and you know they're getting a high background. You know, of course, the radon will flush out right away, but you're still going to have the radon progeny that's built in all night long, giving you background counts. So that's usually the calls we get.
All right, thank you.
You're welcome. Do we have other questions? I'll look around the chat and stuff and see if there's other questions, and I'll try and answer them there. For now, I'll just replay the initial video that some people might have missed. Just to let you know, we also have the live demonstration tomorrow at 12:30. So yeah, feel free to hop on, and we'll show the instrument then. If you check the chat on our booth, there's also a link to the recording of the live demonstration that we did on Tuesday. But anyway, here's the initial video again.
Let's look at how radon enters a house. In this example, we have a fissure in the ground where radon comes up, a gravel layer underneath the house, and footings. The middle footing is a strip footing. The footing on the right has some penetrations and therefore is not airtight. Radon enters the house through openings, such as a crack in the basement slab. So, how does this get mitigated? The usual mitigation process would begin with a communication test, where holes are drilled through the slab. The mitigator would make a larger hole and apply a shop vac to see if there is a connection to the other holes. Normally, that test would be made wherever the most convenient place for a mitigation system would be. In this case, that might be the hole on the far left. In this example, the communication test would reveal that there is communication to the middle hole, but not the far right hole, due to a type of blockage. In this example, it's strip footing, but a blockage could be caused by many things. So, the mitigator would then put the shop vac on the middle hole and hope that it would communicate with the other holes, but in this case, we're still not communicating with the hole on the right. To resolve this, the mitigator would run a jumper to a part of the slab where there was no communication. The theory is that radon is diverted from the crack and is exhausted. The flow through the crack is reversed and the basement air is drawn below the slab and exhausted with the radon fan. The problem with this method is that a lot of energy is wasted sucking in clean air from the outside, and in the winter this leads to cold walls and floors. It also lowers the suction on the other side by pulling in outdoor air, plus now you have a large unsightly jumper. Even worse, the problem might not have even gotten solved. In theory, the mitigator depressurized the entire slab and reversed the airflow through the cracks, but this isn't necessarily the case. The actual pressure at the crack was never measured. There might not even be access to the crack if it is at the expansion joint under a finished wall. Another consideration is that the mitigator may have depressurized the whole slab now, but what about 6 months from now when the water table is different? What about when the house's HRV intake is plugged, depressurizing the house? Maybe then the entire slab will no longer be depressurized with respect to the house. By sucking on the subslab, the mitigator could be bringing in more radon from below. So yes, the airflow through the crack is decreased, but there may have been an increased concentration of radon in that air. Instead of starting with a communication test, some of our customers start by using the Radon Sniffer to check for radon sources. Where a source is found is where the test hole would be placed. Then the mitigator would check for communication to that hole. If there is no communication to a hole that doesn't make up any radon, then there isn't a need to worry about it, and the mitigator would just seal it up. Then the mitigation system would be put where most of the source is, or at least where there is good communication with the source. Therefore, the radon will be moved directly, without first being dragged all over the underside of the slab. Because the test point is close to the radon source crack, the likeliness of not having enough suction to maintain the airflow in the right direction is much less. There also isn't a waste of suction bringing in clean air from the outside.
Okay, so we'll just throw it up for some more questions. Otherwise, this is going to be done. This learning lab is going to be done. Again, join us tomorrow at 12:30 for a live demonstration. And I'll stay on this channel here for as long as there's questions. So thank you, and start your questions.